Welcome to the Deep Dive. We're tackling something really cutting edge today. Agentic AI.
Mm.
Forget AI that just, gives you predictions. We're talking about systems that can actually plan and act on their own to achieve goals.
Yeah, the potential for businesses, for productivity and innovation is just,
Yeah.
it's huge.
Absolutely staggering. But with this new power comes, well, a whole new set of questions around security, doesn't it?
Yeah, it really does. The
Yeah.
traditional ways we've secured AI, they just sort of fall short when you have intelligent agents operating independently like this.
Exactly. And that's what we're digging into today. We've got this fantastic report. It's titled Securing Agentic AI Solutions in the Enterprise.
Right.
It's a deep dive itself, really, packed with practical, globally relevant guidance. And it applies whether you're, messing around with open source stuff or deploying big commercial AI.
Yeah, it provides a much-needed framework, I think, for understanding these security challenges that, well, any organization looking into agentic AI is going to have to grapple with. It's all about enabling that innovation, but doing it securely, right from the ground up.
So our mission today is pretty straightforward. Unpack the vital security considerations for any enterprise thinking about bringing agentic AI into their operations.
Let's do it.
Okay, let's unpack this. What fundamentally makes agentic AI different from, say, the AI we're already kind of familiar with? And why does that mean we need a whole new way of thinking about security?
Well, what's really fascinating here is this shift, right? From AI that mostly analyzes to AI that actually executes.
Yeah.
Think about like your standard machine learning model classifying images or maybe a chatbot answering FAQs.
Yeah, pretty standard stuff.
Right. They operate within pretty clear boundaries. You've got specific inputs, predefined rules, relatively predictable outputs. Agentic AI, it kind of flips that script.
How so?
It has genuine agency. That's the key word. The ability to autonomously decide, okay, which tools do I need? What data should I access? What steps should I take to reach this goal I've been given?
Right, so it's not just processing information anymore.
Right.
It's deciding what information to process and then what actions to take based on that.
Exactly.
The report it uses a really helpful analogy, actually. Thinking of an AI agent as like a new kind of user, maybe, or even a software service that doesn't just analyze data, it acts.
Precisely. And that core difference, that ability to act, significantly broadens the potential attack surface.
Okay.
And it opens up whole new categories of security risks that, frankly, we haven't had to fully consider before in the same way.
All right, so let's drill down into those expanded risks then. What are the major new security headaches that pop up with this increased independence of AI?
Well, the very autonomy that makes agentic AI so powerful, that's also a key security challenge.
Right, the double-edged sword.
Exactly. Because these agents make their own decisions, their behavior becomes inherently harder to anticipate and harder to control.
Makes
Think about prompt injection. You hear a lot about that. Yeah. A cleverly crafted input could basically trick an agent into doing something unintended, maybe even harmful.
Right.
And traditional security measures, they often assume more static, rule-driven behavior. They just aren't really designed to effectively counter that kind of manipulation.
Yeah, if the AI is kind of charting its own course,
Yeah.
you can't just rely on fixed guardrails, can you?
Yeah.
What other new risks are we looking at?
Another critical area is, well, how these agents interact with our existing IT infrastructure. To be really useful, they often need pretty high-level permissions, right, to access corporate databases, APIs, other sensitive systems.
Okay.
Now, granting that level of access to an autonomous, non-human entity, that creates entirely new types of privileged accounts.
Right, which need governing.
Incredibly robust governance, yeah.
Yeah.
And our current identity and access management, our IAM solutions, they were mostly designed for humans, maybe some service accounts. They weren't really architected initially to handle AI agents acting with this kind of independent decision-making power and, frankly, needing such broad access.
So it's kind of like giving a new employee like the keys to the kingdom, but this employee learns super fast and might, use those keys in ways you didn't expect.
That's a pretty good analogy, yeah. And that ties into another key differentiator. Continuous learning and potentially evolving goals.
Oh, great.
Agentic AI systems are often designed to adapt their strategies based on feedback. Their objectives might even change over time.
Right.
Which means security can't just be a one-time setup thing. You can't just set it and forget it.
No way.
We need ongoing monitoring, continuous validation to make sure the agent stays aligned with our security policies as it learns and maybe as its goals shift.
Wow, that sounds like trying to secure a moving target.
Right.
What about data handling? The report mentioned persistent memory.
Yes, that's a really important point too. A lot of these agentic systems, they retain information across interaction.
Like remembering past conversations.
Right. Exactly, or accumulated knowledge about a project or whatever. Now, if one of these agents gets compromised,
Ooh, yeah.
the risk of sensitive data being exposed or misused goes up dramatically, which is quite different from a lot of traditional AI that might just process data transactionally and then discard it.
Okay, so we're dealing with less predictable behavior,
Yeah.
broad system access, continuous learning, persistent data storage.
Yeah.
Are there any other unique aspects adding to this security puzzle?
Oh, absolutely. We're also facing entirely new kinds of attack vectors. We mentioned prompt injection,
Right.
but we also need to think about things like directly manipulating the AI model itself, trying to poison its underlying reasoning, maybe?
Hmm.
Or what's called adversarial data feeding, where you subtly introduce bad data over time to sort of skew the agent's behavior in a harmful way.
Sneaky.
Very. And also, think about where agents get their information. Many are designed to read external sources, right? Websites, documents.
Sure.
Well, if those sources are compromised, the agent's inputs could be spoofed, maliciously altered. And conversely, if an agent generates code or maybe takes actions within our systems, those outputs could potentially be tampered with if the communication channels aren't locked down.
Wow, okay.
Yeah.
It really does sound like we're in a new ballpark for security threats.
I think so.
So just to sum that part up, because agentic AI has this inherent ability to, like, take the initiative and operate independently in complex environments,
Uh-huh.
our security approach needs to go way beyond just protecting data confidentiality or model integrity. We also need to ensure we can actually trust the agent's decisions and actions in real time.
That's precisely the crux of it. It demands a move towards security measures that aren't just stronger, but also much more finely tuned, more adaptable. The trustworthiness of the agent's behavior while it's running, that's paramount now.
All right, so we get the why we need these new security measures. Now let's get into the how. What are the fundamental security requirements enterprises need to establish for these agentic AI solutions?
Okay, so the report lays out several core security requirements that directly tackle these unique challenges we've been discussing.
Yep.
The first one, and you could argue it's the most foundational, is robust identity and access management, IAM.
Okay, familiar term, but how does it apply here?
We need to treat each individual AI agent as its own distinct digital entity.
Like a digital employee?
Kind of, yeah,
Yeah.
with its own carefully managed credentials, its own permissions. So when an agent needs to log into a system or use an API key, it needs to be authenticated and authorized, just like a human user or a traditional service account would be.
But you mentioned earlier that traditional IAM systems might not be fully up to scratch for this.
That's right. Traditional IAM often deals with longer-lasting identities, relatively static roles. Agentic AI really demands a more dynamic, more context-aware approach to privileges.
Okay.
And this is where concepts like ephemeral credentials become really important.
Ephemeral, meaning short-lived.
Exactly. Short-lived security tokens that are only valid for a specific task, maybe for a limited time, they really help enforce that principle of least privilege.
Right.
And they limit the potential damage if an agent's credentials were somehow compromised. We're also seeing a much greater emphasis on zero trust principles.
Zero trust, never trust, always verify.
You got it. An agent's identity isn't inherently trusted just because it logged in once. Continuous verification is needed for ongoing access.
Okay, so strong digital identities for each agent, constantly verified, narrowly defined permissions.
Got it.
Okay. What's the next critical security element?
Well, closely linked to identity management is the need for strong authentication of agents.
Okay, proving who they are.
Right. An agent needs to reliably prove its identity, not just to us users, but also to other systems it interacts with, and even to other AI agents in the same setup.
Agent-to-agent authentication.
Yeah, which often involves mutual authentication, where both parties actually verify each other's identities before exchanging anything sensitive.
How do they do that?
Things like TLS client certificates or maybe digitally signed tokens. Especially in complex systems with multiple agents interacting, you absolutely have to prevent a bad actor from impersonating a legitimate agent.
Makes sense.
And crucially, all communication, whether it's between agents or an agent calling a tool or service, should be cryptographically authenticated to prove its origin.
So it's not enough for the system to recognize the agent. The agent also needs to be sure it's talking to a legit system or another verified agent.
Exactly. That makes perfect sense. And once an agent's identity is authenticated, we need fine-grained authorization and policy enforcement.
Okay, so authentication is who are you? Authorization is, what are you allowed to do?
Precisely. Just because an agent has a verified identity doesn't mean it gets the keys to the city.
Right.
We need strict controls over what actions it can perform, what data it can access. Traditional role-based access control, RBAC, it might be too broad, too static for the dynamic nature of agentic AI.
So what's the alternative?
We need policy engines that can enforce rules based on context.
Like what?
Things like, what's the agent's current task? What's the perceived risk level of the action it wants to take? Maybe even the time of day.
Interesting.
This allows for just-in-time access. Access granted only when needed, and it can expire as soon as the task is done.
Okay.
And if an agent tries to do something it's not authorized for, it should be immediately blocked. Or maybe trigger a secondary approval step, perhaps involving a human.
So it's moving beyond a simple yes-no on access to a much more nuanced, context-aware control system. Feels much smarter.
It has to be. Then we have secure communications. As we touched on earlier, any communication involving the agent talking to another agent, calling external APIs, interacting with an LLM, it must be encrypted while in transit.
Standard stuff like HTTPS.
Absolutely. HTTPS with strong TLS, like TLS 1.3, is essential for all API interactions. Agents often handle sensitive info or get critical instructions if those get intercepted or tampered with.
Bad news.
Very bad news. In multi-agent setups, you might need secure channels or even a communication mesh using mutual TLS to prevent eavesdropping or man-in-the-middle attacks on that agent-to-agent chatter.
Right.
Plus, agents should validate the integrity of messages they receive, maybe using digital signatures, to ensure they're acting on authentic, authorized inputs.
Okay, so ensuring all conversations are happening over a secure private line, and you can verify who you're talking to. What about the actual information the agent processes, the data itself?
That leads us right to input validation and output safeguards. We really need to adopt a zero-trust stance towards all data an agent receives.
Doesn't matter where it comes from. User, database, another agent?
Doesn't matter. All inputs should go through rigorous checks for integrity and safety before the agent processes them.
Can you give an example?
Sure. Say an agent pulls code or instructions from an external source. Before executing anything, it should run thorough syntax validation, maybe check against predefined allow or deny lists. Similarly, if an agent generates code or plans to take actions within our systems, those outputs should ideally be executed in a secure sandbox or a test environment first.
To check they're safe.
Yeah, to confirm they're safe and they behave as expected. This is a really critical defense against threats like prompt injection, and it ensures the agent doesn't just blindly trust potentially dodgy data sources.
So basically creating a safe testing ground before the AI's actions hit the live environment.
Exactly right. And that brings us neatly to execution, sandboxing, and environment isolation.
Sandboxing. Containing the agent.
Precisely. Because agents might execute code, they might make changes to critical systems, invoke external tools. They really should operate within isolated, controlled environments.
How does that work?
Sandboxing restricts the agent's access to resources, CPU, file system, network access. So if it does go rogue or exhibit unexpected behavior,
The damage is contained.
the potential damage is contained within that isolated space. You can use things like Docker containers, micro VMs like Firecracker, even secure enclaves for this.
Right.
And implementing privilege separation within the agent's environment is also key. Making sure the agent's processes only have the absolute minimum OS privileges they need to function. Again, limiting the blast radius if something goes wrong.
So building digital walls around the agent to stop any problems from spreading.
Yeah.
What about keeping track of what the agent actually does? Keeping records.
Yes. That's where audit logging and traceability come in. It's absolutely essential.
Why essential?
Well, maintaining transparent, comprehensive logs of every single action an agent takes, API calls, database queries, decisions it makes, tools it invokes, is critical for security oversight.
For figuring out what happened if something goes wrong.
Exactly. For forensic analysis, and also for demonstrating compliance with regulations.
Right.
It promotes accountability, too, even in these autonomous systems.
Okay.
There needs to be a clear record of why an agent did something and what inputs led to that decision. Audit logs should capture not just the final outcome, but the inputs, maybe significant intermediate steps too. And this detailed logging needs to be paired with real-time monitoring. You need to be able to detect unusual or anomalous activity as it happens.
Like what?
Like an agent suddenly trying to access a huge volume of sensitive data it doesn't normally touch.
Yeah.
that allows security teams to react really quickly to potential incidents.
It sounds like having a detailed flight data recorder for our AI agents.
That's a great analogy,
Okay.
precisely. Now, given that agentic AI often involves handling sensitive enterprise data.
Yeah, customer info, financial records, IP.
Exactly. We absolutely need to address data security and privacy protection. This covers all the standard data security best practices, but with some AI-specific twists.
Touch that.
Well, any sensitive data at rest that the agent uses knowledge bases, vector stores needs to be encrypted, subject to strict access controls. Standard stuff.
Right.
But also, when an agent retrieves data from internal systems, it needs to follow the principle of data minimization, only grab the absolute minimum info needed for the task. And if agents are talking to external large language model APIs, we have to be super careful about not leaking sensitive data in the prompts.
How do you prevent that?
Techniques like anonymizing or tokenizing sensitive info before it goes out. And very carefully choosing LLM providers who offer strong data confidentiality guarantees, like they won't use your data for retraining their models.
Good point.
Context sanitization is also vital. Any logs or error messages the agent generates need to be scrubbed carefully to remove any potentially sensitive stuff.
So it's not just about securing the data stores, but being really mindful of what data we expose, even indirectly during the agent's day-to-day operations.
Exactly right. Finally, because these agents operate with a degree of independence, continuous governance and human oversight are absolutely crucial.
Even though they're autonomous.
Especially because they're autonomous, we need to build in human-in-the-loop capabilities. Governance checkpoint.
Like what? A kill switch?
That's one example, yeah. A kill switch. Or maybe a pause function, allowing human intervention if an agent starts acting weirdly or deviates from its purpose.
Okay.
There should also be clearly defined policies. Which decisions can the agent make on its own? Which ones need human approval or review?
Setting boundaries.
Right. Regular audits of the agent's decision logic and its outcomes are also necessary to ensure ongoing alignment with ethical guidelines, compliance standards, and ideally, agents should be designed to provide some level of explainability for their significant decisions. That transparency builds trust and really helps with human oversight.
So even with AI that can act independently, we still need ways for humans to step in and ways to understand why it did what it did. These security requirements, they paint a picture of a much more intricate security landscape than maybe we're used to.
They absolutely do. And to maybe make this a bit more concrete, we can look at how these requirements translate into practical steps in specific enterprise security use cases.
Great. Yeah, let's look at some real-world examples. How do these security requirements actually play out when we're trying to, say, authenticate an AI agent? How does that work in practice?
Yeah, this is a foundational challenge, right? As we said, traditional auth methods weren't really built for AI agents needing API access, database access, LLM service access.
Right.
So the report highlights several emerging best practices. One key one is using ephemeral credentials.
Those short-lived tokens again.
Exactly. Instead of a static, long-lived API key, the agent uses a service, maybe AWS STS, Azure AD Oath, to get a temporary, narrowly scoped token just for that session or task.
Like a temporary access badge that expires automatically. I like that.
That's a good analogy. Another concept gaining traction is dynamic identity.
What's that?
Well, maybe the agent temporarily assumes a user's identity for certain specific actions that need that level of privilege.
Wow.
But otherwise, it operates under its own unique system identity for less sensitive stuff. We're also seeing development in federated identity solutions.
Federated, like single sign-on for agents.
Kind of, yeah. The goal is to give agents a consistent identity profile that can be verified across different systems. So an enterprise might assign each agent a unique service principal, then use standard protocols like OAuth behind the scenes to manage access. A bit like using your Google account to log into various websites.
So giving the AI its own secure, verifiable passport for different services. Got it.
Precisely. And when agents need to connect to internal services, mutual authentication becomes really important.
Both sides verifying each other.
Right. The service should verify the agent's identity too, maybe using mutual TLS or signed requests. The service needs to trust the agent, just like the agent needs to trust the service. Crucial in complex microservice setups.
Yeah, makes sense.
Then there's the critical bit, secure credential management. No hard-coding API keys or secrets in the agent's code.
Please no.
Right. Enterprises absolutely should use secure vault solutions, HashiCorp Vault, Cloud KMS, that kind of thing, to store and retrieve credentials securely at runtime. The report even mentions 1Password's Agentic AI security module as a real-world tool specifically for this.
Okay.
The goal is basically authenticate these non-human things with the same rigor as humans, but using methods suited for automation.
Right. Automation friendly, but just as secure. Okay, so we've got secure identities and verification. What about when these agents need to talk to each other? How do we handle secure agent-to-agent communication?
Yeah, in more sophisticated setups where you have multiple agents collaborating, securing their interactions is vital. The report really emphasizes using encrypted channels for all communication between agents.
Like TLS on message buses?
Exactly, or even end-to-end encryption for really sensitive data exchanges. Prevents eavesdropping, unauthorized interception. We also need robust authentication and authorization between the agents. Each agent should be able to confidently verify the identity of the agent it's talking to, maybe using shared secrets, digital signatures.
Right.
And just like with users, not every agent should be allowed to talk to every other agent. You need clear, granular communication permissions based on their roles and responsibilities.
So it's not just securing the pipe, but also verifying who's at each end and what they're allowed to say to each other.
You got it. Other important measures include things like rate limiting, preventing one agent from just flooding another with requests,
Uh-huh.
and rigorous validation of message content to guard against malicious payloads or denial of service attacks between agents.
Okay.
And finally, where it makes sense, isolating agent networks, maybe using segregated network segments. Private container networks can really minimize the potential for unauthorized agents to even make contact.
Makes sense. Limit the opportunity.
Essentially, securing agent-to-agent communication is about extending zero trust principles to the entire agent ecosystem.
Okay. Now, a huge part of many agentic AI systems is their interaction with large language models, the LLMs. How do we ensure secure access to LLMs and AI models?
This is truly critical, yeah, because the LLM is often the agent's brain, its reasoning engine.
Right.
So for agents talking to third-party LLM services, robust API key management and call security are paramount.
Secure storage, secure transmission.
Absolutely. Keys stored securely, ideally in vars or vaults, all comms over HTTPS, ideally from within a secure network. It's also really advisable to choose enterprise-grade LLM providers.
Why enterprise grade?
They usually offer enhanced security assurances, like explicit guarantees your data won't be used for retraining their models, strong confidentiality commitments.
Gotcha. Important distinction.
For organizations with super sensitive data, an alternative is local or private model deployment, running the LLM on your own secure infrastructure.
More control, but more work.
Exactly. And in that case, the model server itself needs rigorous security, maybe running in isolated environments or even trusted execution environments, TEs.
Okay, so controlling who talks to the LLM, where it happens, and the privacy guarantees.
Precisely. Plus, prompt input sanitization is absolutely crucial.
To avoid leaking secrets.
Yeah, or injecting harmful instructions. And we can't overlook model output validation, the stuff the LLM generates. Treat it as potentially untrusted until checked.
Like if it generates code.
Exactly. That code needs rigorous security scanning before you even think about executing it. This whole use case is basically extending application security practices to that AI agent to LLM interface.
Okay, makes sense. We've covered authentication, agent communication, LLM access. Now, what about when agents need to interact with the wider enterprise IT world? Databases, external APIs, third-party tools. How do we ensure safe integration with external systems and tools?
Yeah, this is where the agent's ability to take autonomous action really shines, but it's also where things can get risky if not managed carefully.
I bet.
The report hammers home the importance of scoped API access with least privilege.
We'll only give it what it absolutely needs.
Exactly. If an agent only needs read access to one specific dataset in Salesforce, its API credentials should grant exactly that, nothing more. Many places are creating dedicated service accounts with super restricted roles just for their AI agents.
Smart.
Another crucial practice, tool whitelisting within the agent framework.
Meaning?
Limiting the agent so it can only invoke tools from a predefined approved list, prevents it from calling potentially dangerous or unauthorized functions.
So you're not giving the AI a massive toolbox when it only needs a screwdriver for this one task.
Exactly right. And every time an agent does invoke an external tool or service, that interaction needs to happen over secure channels with thorough input sanitization.
Like preventing SQL injection.
Classic example. If an agent builds a database query based on user input, it must use parameterized queries. We also need to monitor external access really closely. API logging, maybe CASB or API gateway solutions to spot anything unusual. And finally, the report strongly recommends sandboxing the responses and actions from these external tool calls.
With a dry run.
Kind of, yeah. For potentially risky operations, maybe the agent does a trial run in an isolated environment first to see what happens before doing it for real on production data.
Okay.
The overall goal here is just ensuring that when agents reach out, they don't accidentally become conduits for attacks on other systems, and that all their interactions are tightly controlled and governed.
These specific use cases really bring it home, don't they?
Yeah.
How those abstract security requirements actually translate into tangible practices. It's clear securing agentic AI needs a really comprehensive, layered approach.
It absolutely does. And to make all this actually happen, enterprises need to build specific security capabilities and put the right controls in place. Some might seem familiar from traditional cybersecurity,
Right.
but they often need adapting, augmenting for these AI agents.
Okay, so let's delve into those essential security capabilities then. What are some of the key things organizations need to build or enhance to secure their agentic AI work effectively?
Well, building on what we discussed, the first essential capability is establishing identity and access management specifically designed for AI agents.
Going beyond just a simple AD.
Right. It's managing their whole life cycle, secure credential issuance, rotation, defining roles, permissions, and crucially, being able to clearly distinguish them from human users in your IAM systems.
Why is that distinction so important?
To prevent risky hard-coded or shared credentials, avoid that shadow AI problem where agents pop up ungoverned, and enable proper auditing of what the agents are doing.
Makes sense. What kind of solutions help here?
Well, you can leverage existing IAM platforms, treating agents like specialized service accounts, but we're also seeing more purpose-built tools emerging, like 1Password's EAM, offering dynamic secrets, least privilege enforcement for agents. Cloud providers have temporary credential services too. The Cloud Security Alliance actually recommends combining secrets managers with access brokers for robustness.
Okay, so extending existing IAM, but maybe adding specialized tools too.
Exactly. The next critical capability is implementing zero trust principles and enforcing continuous authorization.
That never trust, always verify ID again.
Right. We can't just trust an agent based on one login. We need to continuously verify its actions, strictly enforce least privilege throughout its operation.
Why the constant checking?
Because an agent's intent or the context it's working in can change, or it could get compromised. Continuous checks catch those issues early.
How do you do that technically?
Deploying policy engines like Open Policy Agent, OPA, using context-aware access controls, leveraging condition-based cloud IAM policies, using monitoring tools that flag abnormal behavior, even simple things like session limits requiring periodic reauthentication help.
Okay, moving away from trust after login to constant ongoing verification.
No.
Got it.
Precisely. Then we have the capability of establishing secure execution environments, sandboxing.
Running the agents in a safe little box.
Basically, yeah, running agents and any code they generate in isolated environments that tightly restrict their access to system resources, network connections.
Why is that so vital?
It limits the damage if an agent goes rogue or acts unexpectedly. Plus, it provides a safe space to test potentially risky actions the agent might want to take.
What technologies do people use for sandboxing?
Containers like Docker, Kubernetes, lightweight VMs like gvisor, Firecracker, even browser-based sandboxing sometimes. Some libraries, like NVIDIA NeMo guardrails, emphasize running AI-generated code in sandboxed interpreters. Often, enterprises need to build their own safe execution wrappers specific to their agents.
Okay, creating a secure, contained playpen for the AI.
Exactly. Another fundamental capability, encryption and comprehensive data protection. Data at rest, data in transit.
Protecting the data everywhere.
Absolutely. Agents handle sensitive data across systems. Robust encryption is vital to prevent exposure if there's compromise.
So standard encryption tools apply.
Yes, standard tools are key. Database encryption, TLS for all agent communication, using enterprise KMS for key management. We're also seeing specialized solutions like Skyflow for data tokenization. And crucially, Configuring cloud AI APIs to not store your interaction content is a big one.
Right, protecting the data throughout its whole journey in the agent ecosystem.
You got it. Then we have the critical capability of robust monitoring, logging, and comprehensive audit trails.
Visibility and record keeping.
Essential. Continuous oversight of agent behavior, detailed records of all activities, needed for real-time anomaly detection and for forensic analysis if something goes wrong. With autonomous agents, constant vigilance is key.
What tools help with this?
Centralized logging platforms, SIMs like Splunk, Elastic, specialized LLM monitoring tools like Helicone or LangChain, plus AI observability platforms like Arise AI or Y Labs that can spot unusual patterns in agent outputs. And integrating this with incident response plans for automated actions is important too.
Providing the eyes and ears and the historical record needed to manage these agents.
Correct. Next up, implementing effective input sanitization and output guardrails.
Filters and checks on what goes in and what comes out.
Exactly, to ensure safety and compliance. The main goal is preventing malicious or inappropriate content from messing with the agent's behavior or being generated by the agent and leaking out.
What kind of tools offer this?
Prompt filtering mechanisms, content moderation APIs from LLM providers like OpenAI and Azure, specialized frameworks like NVIDIA NeMo Guardrails or the open source Guardrails AI let you define specific rules and validations for LLM outputs. Output validation for external tool use is key too. And we're seeing dedicated AI firewalls like Lasso Security emerge.
Building a protective shield around the AI's interactions, keeping them safe and appropriate.
That's the idea. And finally, we need the capability of establishing a secure development lifecycle specifically for AI agents.
DevSecOps for AI.
Basically, yes, integrating security into every phase, design, development, testing, deployment. Because these things are often built fast, security can get overlooked.
So how do you integrate it?
Things like threat modeling tailored for AI agents, security reviews of prompts and tool selections, comprehensive testing unit tests, red teaming, using infrastructure as code for policies and deployments, making security part of the build process, not a bolt-on at the end.
Making security integral, not an afterthought. Got it.
Precisely. These capabilities, even though some are more mature than others, are the essential building blocks for a strong security posture when you're dealing with agentic AI.
Okay, so we have a solid grasp of the requirements and the capabilities needed. But let's be real for a second. How mature is the security landscape for agentic AI right now? What are the big gaps and limitations organizations are actually facing today?
Yeah, that's a really important reality check. While the excitement and innovation are moving incredibly fast, the truth is security readiness is generally lagging behind this early adoption curve. We're seeing more of what the report calls shadow AI.
Meaning?
Autonomous agents being piloted, maybe even deployed, within organizations without the full awareness or direct oversight of the security teams. Yeah. And a mature, widely adopted security framework specifically for agentic AI, they're still really in the early stages, very early.
That sounds like a recipe for potential problems down the line.
It is. We're also seeing significant gaps in traditional identity and access management systems. Like we discussed, they don't fully handle the ephemeral identities, the dynamic sessions needed for AI agents very well.
So companies are having to patch things together.
Often, yeah. Manually extending or adapting existing IAM models, which can be complex, error-prone, and establishing robust, policy-based trust patterns for these autonomous agents. That's still pretty nascent.
So our current identity infrastructure isn't quite a perfect fit yet.
Not quite. Plus, a lot of the popular open-source agent frameworks, understandably, in their early days, they prioritize getting the core functionality working, making it easy to use.
Over built-in security.
Often, yeah. While they're increasingly adding some basic security precautions, the main responsibility for implementing really comprehensive security controls still falls heavily on the organizations and developers using them.
So there's a significant DIY security element right now.
There often is, and while we're seeing best practices emerge from places like the Cloud Security Alliance, NIST, there isn't yet a universally adopted, detailed security framework specifically for agentic AI, not like OWASP for web apps or ISO 27001 for general security. The NIST AI risk management framework offers great high-level guidance, but that deep, granular standardization for agentic AI specifics, it's still lacking.
So we're still figuring out the detailed standards for this fast-moving area.
We really are. We're also seeing notable gaps in tooling and automation for agentic AI security. For example, prompt injection defense. Lots of active research, but no silver bullet tool yet that guarantees detection and prevention. Similarly, AI-specific sandboxing solutions that are both robust and performant, still evolving. Mature debugging tools that give deep insights into why an agent made a certain decision, also still under development. Our ability to fully understand, monitor, and secure these complex systems is still catching up.
So the security tools are getting better, but maybe not quite keeping pace with the AI's complexity yet.
That's a fair way to put it. And there are inherent performance trade-offs too, right?
Security versus speed.
Often, yeah. Implementing really heavy security can sometimes slow down an agent's responsiveness, which might be critical for its job. Finding that right balance, especially for low-latency agents, is an ongoing challenge.
Okay.
And finally, there are often, frankly, cultural and skill gaps between traditional security teams and these newer AI development teams that can lead to misconfigurations, blind spots, just a lack of shared understanding of the unique risks.
Bridging that gap sounds important.
It is. But the good news is awareness is growing fast. We're seeing more educational resources, training, AI security playbooks emerge to help bridge those gaps.
So it sounds like we're in this dynamic phase, rapid innovation, but also a rapidly growing understanding of the security side.
Exactly. But importantly, as we've discussed, there are already valuable solutions and tools available that enterprises can start using today to improve their agentic AI security.
Okay, let's talk about those then. What are some key categories of solutions, maybe specific examples, that can help organizations right now?
Sure, we're seeing solutions across several critical areas. For identity and credential management, you've got existing cloud IAM platforms, AWS IAM, GCP, Azure AD, plus established vaults like HashiCorp Vault, Azure Key Vault, 1Password EAM, and newer IAM extensions focusing on non-human identities.
Okay. What about securing the network?
For network and communication security, standard TLS, MTLS frameworks are foundational. Service meshes like Istio or Linkerd help manage encryption and auth between services. And good old VPN VPC isolation still matters.
Right. And those guardrails for prompts and outputs.
For prompt and output guardrails, there are specialized frameworks like NVIDIA NeMo guardrails, the open source Guardrails AI, plus LLM provider moderation APIs, and dedicated AI firewalls like Lasso Security are popping up.
Sandboxing tools.
For execution sandboxing, you've got Docker, Kubernetes, lightweight VMs like gvisor, Firecracker. Some agent frameworks have built-in tool restrictions too.
Monitoring and logging.
Monitoring and auditing. Established logging schemes like ELK, Splunk, Datadog are crucial. Add to that newer LLM usage monitors like Helicone, LangChain Plus, ALOC, and AI observability platforms like Arise AI, YLabs for deeper insights.
Right. Policy enforcement.
Policy enforcement and governance. Tools like Open Policy Agent, OPA, are useful. Cloud provider compliance rules help. And referencing frameworks like NIST AI, RMF, and CSA guidelines provide structure.
And finally, testing.
Testing and validation tools. We're seeing adversarial testing tools like Microsoft Counterfeit, adapting standard unit test frameworks, and using simulation environments more.
It's actually encouraging to see that even though it's early days, there's a growing ecosystem of tools available.
Absolutely. And it's crucial to remember this is just a snapshot, right? As of 2025, new solutions are coming out incredibly fast.
A constant evolution. So, given this dynamic environment, what are some specific, actionable recommendations? What can enterprises do right now to start building a strong security posture for their agentic AI work?
Okay, yeah, the report gives several key recommendations. First and foremost, integrate your AI agents into your existing security architecture.
Don't silo them off.
Exactly. Don't treat them like weird science projects. Onboard them into your identity directory, give them unique IDs, apply RBAC where it fits, leverage your existing IAM, PEM logging systems.
Okay, integrate them. Don't build a separate security world.
Right. Second, start with least privilege and grant permissions incrementally.
Start small.
Yes. Give agents the absolute minimum access needed initially, then carefully expand permissions only as you gain trust and understand their needs better. Limits the blast radius.
Makes sense.
Third, use ephemeral and narrowly scoped credentials extensively. Ditch the long-lived broad keys. Use short-lived tokens from a secure broker. Store secrets in vaults. Never encode or config files.
Short-lived targeted access keys.
Yeah.
Minimizes risk. Good.
Fourth, Implement comprehensive logging and monitoring from day one,
Even in development.
especially in development. Log all agent actions, decisions, aggregate logs in your central SIEM. Set up basic alerts for unusual activity. Log prompts and outputs too, but sanitize sensitive data carefully.
Visibility from the start.
Fifth, proactively apply your existing AppSec and data security best practices. Do threat modeling specifically for your AI solutions. Use encryption everywhere sensitive data is involved. Extend your DLP measures to cover agent communications.
So the fundamental security principles we already know still absolutely apply.
They really do. Sixth, invest in educating and training all the teams involved. Bridge those knowledge gaps between AI devs and security teams. Workshops, shared training, open communication, shared understanding is crucial.
Get everyone on the same page.
Seventh, actively leverage available frameworks and stay continuously updated. Keep an eye on guidelines from CSA, NIST. Stay informed about vendor security features. This field changes fast. Continuous learning is essential.
Staying informed is key, yeah.
Exactly. Eighth, implement robust guardrails and test them rigorously. Both technical guardrails in the system and procedural ones in your processes, and then actively test them, red teaming, pen testing. Don't just assume they work.
Build fences, then rattle
A
them.
good way to put it. Ninth, develop comprehensive fail-safe mechanisms and incident response plans. Assume things will go wrong sometimes. Have clear plans to contain, isolate, recover, including that kill switch capability if needed.
Plan for failure.
And finally, 10th, adopt a phased approach to increasing autonomy, coupled with ongoing human oversight. Start with limited autonomy, lots of human checks. Gradually increase independence only as you gain confidence in secure operation and your ability to monitor and control.
A gradual, controlled rollout, building trust along the way. Sounds very prudent.
It really is. By implementing these recommendations, enterprises can take meaningful steps today to secure their agentic AI solutions and start harnessing that transformative potential safely and responsibly.
This has been an incredibly insightful deep dive. Really illuminated the crucial security side of agentic AI. It's so clear that while the potential is just enormous, a security-first mindset is absolutely paramount, isn't it?
It truly is. I think the key takeaway is that we need to adapt, maybe augment our established security principles to really handle the dynamic, autonomous nature of these AI agents effectively. Security can't be an afterthought. It has to be woven into the fabric of these systems to build and maintain trust.
Absolutely. And as we look towards a future where autonomous AI might play an even bigger role in how businesses operate and decision-making, it really does prompt a fundamental question, doesn't it? Given this increasing autonomy of AI systems, how will our traditional concepts of accountability, of responsibility, how will those need to evolve within enterprises? It's a huge point to consider, I think, extending way beyond just the technical security controls we've talked about today.
Indeed, it does. It raises some profound questions ones will undoubtedly keep grappling with as this field matures, and its impact really deepens within our organizations.
Thank you so much for joining us on this deep dive. We really hope this discussion has given you, our listeners, valuable insights into navigating both the security challenges and the immense opportunities presented by agentic AI.